So now you will learn how to clear a range of bits. So the problem is like this: given a number n and a position I, we want to clear all the last I bits of that particular number, right? So I bits from the right. So for example, if the number is like this, let's say n is of this form 100010001, right? So now maybe I is given as, let's say, 3 0 1 2 3. So we want to make all of these bits as zeros. So we want to put zeros here, and we would like to retain this particular number as it is. So this should be your answer, right? So if you clearly see what you will have, you need to have 1 at those positions which you want to retain, and you want to have zeros at those positions which we want to do the discard. So clearly you need a mask of this form 1 1 1 1 1 1 1, and you need to have zeros at these positions, right? So you need to create a mask of this form. Okay, so let's see how do we create this type of a mask, right? So one thing we can do is we can start with all ones. Okay, in the starting you can have all ones. So let's say you have a 32-bit number in which all ones are there, right? So how do you create this number, right? Again, to create this number you have two ways. Okay, so this number is actually nothing but -1, right? So remember, -1 in 2's complement form is stored as collection of all ones. So either you can say, okay, my starting number is nothing but -1, or you can say I will flip all the bits of 0, right? So if you have all zeros in 0, and if you flip all the bits, then it will also become all ones including the sign bit. So this, and if you do cout 0 also, right? If you try to do cout 0 also, this number will be -1, and you can just verify, right? If I do cout not of 0, so this is same as writing -1. Okay, so maybe just return 0. Okay, let me just show you if you're not sure. So you can see this number is actually -1. Okay, so we can start with all ones, and then you can say, okay, I will left shift it by I number of places. Okay, so if you left shift this thing by I number of places, what you will have, all ones followed by I zeros here. So you will have I zeros, and all other digit will be ones. So this is something that we exactly need in this question. So now how do we clear the last I bits? So once you have the mask ready, so mask is nothing but you start with -1 and you left shift it I number of times, you have the mask. And how do you update the number? So you do n equals to n and mask. So once you do the and, you will discard the last I bits and you will retain all other bits, and you will get the updated number. So let's write it in the form of code. So you have mask, which is -1 left shift I, and you can also do return this case n and mask. This is your answer. Okay, so let's test our code. Let me just commit this thing, and let's say n is 15 this time and I is 2, which means I want to clear the last 3 bits. Okay, so 2 means effectively 0 1 and 2. I want to clear the last 3 bits from the position I, right? So from position I to 0, so we would be clearing out 3 bits. So cout clear last I bits, and in this case I can give n and I. So let's run the code. Okay, so it's saying Let's verify, right? So 15 is like this, 0, 1, 2. Yeah. So yeah, there is small mistake here. So clearing from, not from position, but from position I plus 1, right? So when I say clear last two bits, and when I create a mask like this, I left shift it two times, so it will create something like this, and this will clear only two bits, right? And once you do this thing with 15, okay, so you will retain these two bits. So this is 8 plus 4, 12. So you're left with 12. So if you want to clear 3 bits, if you want to clear last 3 bits, you have to give I as 3. So this I is exactly the number of bits that are getting cleared, right? So it's not the position, but the number of bits that are getting cleared. So in this case, our answer should be 8 now. So yes, we are getting 8, right? So that is working perfectly fine. So we are able to clear last I bits. Okay. The next is we want to clear a range of bits from I to J. So this is a one level higher than what we have solved. So we want to clear a range of bits from index I to J. Okay, so this time we are given two indices and we want to clear out a range of bits. So for example, your number is something like this, 1 1 1 1 1. This number is 31, okay, and let's say I want to clear out this position 0 1 2 3 4. Let's say I want to clear out from these positions, so I is 1, J is 3. I want to remove these bits, so I can say 0 0 1 0 0 0 1 would be my final answer, right? So clearly we need to create a mask which is going to have 0 at these places. So mask will be 0 at these places and it will have all other places as ones. So we need to create something like this now. So let us see how we can create this type of a mask now. Okay, so let's see. So again, what we can do is we can start with we can break this mask into two components, right? So let's start with all ones. Okay, so first of all we will create a mask. So you have some ones in the beginning, then you have some zeros, then you have some ones, zeros, ones. So this is the type of mask that you need in this type of a problem. So what we can do is, if we have a mask in which you have lots of ones followed by zeros, okay, you have from the jth position onwards till the 0th position you have everything as 0. And suppose you also have a mask in which you have ones starting from the I plus 1th position till 0, right? And if you do an OR of these two masks, you will get the final mask. So you will get 1 1 1 followed by 0 0 0 followed by 1 1. Something like this you will definitely get. Now let us first focus upon how to build this part. Let's call it A, let's call this as B, let's call this mask, and let's say this is A or B. Okay, so A is the left part of the mask, B is the right part of the mask, and mask is the OR of both. Okay, so A part is easy. How do we create a A part? So like we have done earlier, we can start with all ones. So how do we create all ones? So you take not of 0, this gives you all the ones, or you start with -1, then you left shift it. Okay, so jth index, right? So how many zeros you want to insert here? J plus 1. So you left shift it J plus 1 times. So this gives you the A part. So this is A. Okay, let me write more clearly. So A is nothing but you start with all ones, and you left shift it J plus 1 number of times. So that will effectively give you j plus 1 zeros up to jth index, right? So you have up to jth index. From 0 you will have everything as 0, so this will give you ones followed by zeros. This is j. Then let's see how you can create the b part, right? So in the b part you need to create a number like this. You have ones here, right? So and whenever you want to create a number of this form, what you can do is, this number is nothing but this number is of the form 2 raised to the power n minus 1. So let's say if n is 4, then 2 raised to the power 4 is 16, minus 1 it is 15. So you get 0 1 1 1. So effectively you get 4 bits here. If you say if you want to have 3 bits here, then you can say okay, 2 raised to the power 3 minus 1, this number is 8, minus 1 is 7, and this is how you represent 7. So 7 has last 3 set bits and all of them are ones. Okay, so in this case you want to have how many bits here? Okay, so clearly we need to have I number of bits here. Okay, I number of bits here. So we can say b part is nothing but 2 raised to the power I minus 1. So this can be written as 1 left shift I minus 1. So 1 left shift I means 1 followed by I zeros, 1 2 3 4 5. So these are I zeros, and if you subtract 1 out of them you will get I number of ones. So this is I number of ones. Okay, so now we have I number of ones here, right? Okay, so what we can do now is we can do an OR. So our mask will be now A or B, right? And finally, in order to clear out the numbers, we can say number equals to number and mask. Okay, so these are the 4 steps that we will follow to solve this problem. So calculate A, calculate B, calculate mask, and update your number. So this will help us to clear all the bits from I to J. So let's write the code now. So let's start with ones, which is not of 0. So left part will be, which is our A, right? So A will be ones left shift J plus 1, and then we have the B part, which will be 1 left shift I minus 1, and then we will have mask, which is equal to left A or B, and then we have our answer, which is equal to n and mask, and finally we say return answer. So okay, so what I can do is I can take the number as, let's say, 31 this time, and I can say okay, I is 1 and J is, let's say, 3. Let's see what this does now, and let's do cout clear range I to J, and n is n, I is I, j is j. So this gives me an answer of 17. So let's see what is 31. So 31 means zeros followed by 1 2 3 4 5, and I is in this case 1 and j is 3. Okay, so I is 1 0 1 2 3 4, right? So we are getting the answer as 17, which means we are able to clear out these bits. I is 1, j is 3. So if you clear out these bits, you are left with this 1 followed by 0, and you are getting this 1. So clearly this is 2 raised to the power 4, this is 2 raised to the power 0. So 16 plus 1 is 17, which means our solution is correct. So that's all for this video. Thanks a lot.